My name is Miriam, and today I'm going to explain thermochemistry. Basically, how heat and energy work in chemistry. You see thermochemistry every day, from cooking food to feeling the warmth of the sun. So let's break it down. Energy comes into two main types, kinetic and potential. Kinetic energy is the energy of moving. If something is moving, it has kinetic energy. For example, a running person, a moving car, boiling water. Potential energy is stored energy. It's energy waiting to be used. For example, a stretched rubber band, a battery, a ball at the top of a hill. Energy can be created or destroyed, only change from one form to another. This is called the law of conservation of energy. For example, when a roller coaster goes down, a potential energy turns into kinetic energy. The third one I'm going to talk about is endothermic versus exothermic reactions. Reactions can either absorb or release heat. Endothermic reaction absorbs heat, so they feel cool. For example, icing milk, boiling water, cooking, and etc. Exothermic reactions release heat, so they feel hot. For example, fire burning, freezing water, explosions. So if you ever touch something and it feels cold, heat is going into it. If that feels warm, heat is coming out. Heating and cooling curves. When something heats up or cools down, its temperature changes. But during fast changes, like melting or boiling, the temperature stays the same because energy is being used to break bones. For example, ice melting, temperature doesn't change until all the ices melt. Phase change diagrams. This diagram shows how pressure and temperature affect phase change at a certain point called the surgical point, and substance can be both in liquid and gas at the same time. Colorimetry. Colorimetry is how we measure heat energy. The formula is like K for is heat energy, M is for mass, C is for specific heat, and the triangle with the D is temperature change. For example, if we heat 100 grams of water from 20 centigrade to 60 centigrade, we can calculate how much energy is absorbed. So for the calculation, today we learned about kinetic versus potential energy, endothermic versus exothermic reactions, reaction pathways, heating and cooling curves, fast change diagrams, and colorimetry. Next time you drink hot water or watch ice melt, remembering thermochemistry is all around you. Thank you so much guys for watching my video. Y'all have a good day.